Alright, so this is 1.6b, the second part. So I'm on page 136. In 1.6a, we're talking about functions and about sums, differences, products, and quotients of functions. And on example 2 on page 136, let's write that up here again. We were given f of x equals x squared minus 4, and we are also given g of x equals x plus 2. Now what they're asking us to do is to find the domain of f plus g and f minus g and fg and f over g. Alright, so let's look at the f plus g. What do we know about the domain of f? What does it include?
All real numbers.
All real numbers. What's the domain of g have?
All real numbers.
Okay, so when we add those, when we subtract them, when we multiply them, when we divide them, we take the intersection of the domain of f and the domain of g. So what is the intersection of f and g? All real numbers. Okay, so that works for this, 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 but what makes a domain not possible when you're dividing? What about the denominator?
It can't have a 0.
Okay, so g of x equals x plus 2 cannot equal 0 because it makes it undefined. So, when we're dividing, is g the set of all real numbers? Do all real numbers work for g? Can we plug any number we want into this equation and get a number other than 0? What number does not work, Kelsey? Negative 2 makes our denominator undefined because we put negative 2 up here. It gives us negative 2 plus 2, which is 0. Which means that instead of us writing for a domain all real numbers, we have to do the negative infinity to negative 2 unions negative 2 to positive infinity. We have to say that we are not counting negative 2 in our answer. Okay? And that's what this means. Because of the rounded here on negative 2, we're saying we're not including negative 2 in our domain.
And the only reason you would use the union sign is just so you could use every number before and beyond.
Exactly. Okay. That union sign takes... What it does is it takes the interval of real numbers and splits it up into, in this case, 2 intervals. Meaning there's some answers that aren't going to work. So that's kind of what the U is. The U is all the numbers that don't work. And then on either side of it are the ones that do work. Okay, so yes, good point. Something that I do want to bring up though, putting this f of x equals x squared minus 4, and our g of x equals x plus 2. Alright, so when we are dividing those, when I had the f over g, if you do this, and you're going to do the math, difference of 2 squares, those cancel. So we get, for the division for f over g, we get x minus 2. Okay, what is the domain of that? It's a set of real numbers, right? Every number, if we plug in for x and we take 2 away, we will get something that exists, right? A positive or a negative real number. We're not getting an imaginary number because there's no square root of a negative. and we're not getting an undefined number because there's no fraction. So, the answer is the set of real numbers. But a minute ago, Kelsey just said negative 2 didn't work. So what's the problem here? The problem is we determined our domain after we factored. You need to figure out the domain prior to factoring, because then you end up with the whole extraneous root thing like Adam was talking about earlier. So make sure you determine your domain prior to doing all the canceling and stuff, because when you cancel, negative 2 does work because we got rid of the denominator. Okay, so something to remember. Alright, so the drawing that I have on here is also found on page 137 in the left-hand margin. Just want to go through what we've done here. We've got a function. The orange curve is a function. Then we've got two black dots there where the orange curve and the purple line intersect. Notice that I named the lower intersection x f of x. So what the x refers to is whatever value that x is. We don't know. I didn't give one. I mean, it could be 2, 3, 4, 5, you know, whatever. But since I didn't give it one, we just call it x. The y value, or the amount of intervals that you move up, right, rather than calling it x, we're calling it f of x. Or I'm sorry, rather than calling it y, we're calling it f of x. So we go over to the right x, and we go up f of x. Okay? The right-hand side is not some random value. It's over to x plus the distance between x and the next point. Okay? In this case, that distance is h. Okay? So if I were to draw a graph over here, and I were to number these, and I were to put 1, 2, 3, 4. Okay, so this is 4 and this is 1. If this 1 here is my first x, my 4, let's say I don't know it, would be x plus h if h were this distance. Okay? So if I didn't know what my numbers were, and I assigned x to number 1 and x plus h to number 4. Do you see how that works? If x was 1, what is the h value? 3. So x plus h, 1 plus 3, is 4. So that's where the 4 came from. So do you see how that works? Okay. All right, same thing with my y values. In order to get this y value right there, I had to take x plus h, plug it into the function machine, and get a y value out so I knew how high to go up. And instead of calling it a y value, we call it f of x plus h, whatever value that was. So for instance, if we took 4 and plugged it into that machine, what y value would it spit out so I would know how far up to go up to find that point? I know how far over to go, 4. Now I have to figure out how high up to go, and when I plug 4 in, it's going to kick out a y. In this case, when I plug x plus h in, it's going to kick out f of x plus h. Does that make any kind of sense at all?
Yes.
Okay, good. All right, let's get rid of some of this, because it's very important to understand what that x plus h and the f of x plus h and all that represents. All right, that purple line I have there. You guys have seen this word before. Secant. When have you seen secant?
Last year.
Yeah, it was the 7th circle of Dante's Hell. No, I'm kidding. Trigonometry, you will be doing secants next semester. But that's what a secant is that line, that purple line. What is the difference between a secant line and a chord?
Is
Remember? secant lines go on and on and on. They go through, they intersect the graph, whereas a chord stops, like in a circle. It goes like a diameter is a chord. It goes from one end of the circle through the center point to the other end. It doesn't continue on. It stops. So a chord is a part of a secant. Okay, but that's just what it's called, is a secant. So what we have is...
Where the y2 minus y1 over x2 minus x1.
Go. Okay, so slope is... Let me get a pen here. Slope is y minus y, x minus x. And there was another way that we were using to express that using a Greek letter. Remember? Yeah, change in y over the change in x. All right. So, my question then is there a way using this graph up there that I can write the change in y over the change in x using the x and the x plus h values on that graph over there? Okay, so while you're thinking about that, let me again draw another graph here with numbers on it. And let's say that I have a line right here. Let me get this up here real quick, and then we'll do some... let's say that that is 2, 2. Now let's say it's 2, 1. I don't want to use the same numbers. And let's say that that point is 4, 3. Okay, so what's the change in y up there? Change in y.
2.
Okay, so it's 3 minus 1 is 2. What's the change in x?
2.
And you got that from 4 minus 2. Okay, we're going to do the exact same thing with this graph over here with the red graph. Let's erase all this since you already have that figured out. All right, so what is the change in y?
F of x plus h minus f of x.
F of x plus h minus f of x over what?
X plus h minus x. Oh, it's an h.
Yes, I'm sorry. This right
That
here?
was an a. Yeah.
Yeah, that's an h. Yeah. Okay. So we've got that. Cool. Works great. Can I cancel? Can I simplify that fraction that I have right here? Tim?
Yes.
To what?
F minus F. Can you cancel the x off of? No.
Like that?
Minus, no, F minus F of x over, since they're,
Okay, so because we have, let me use my cool orange circle. Because the numerator is functions, you cannot cancel the x plus h or the x. The function forces you to leave those parentheses on there. The denominator, on the other hand, doesn't have an f. So you can take the parentheses off and take x minus x and get 0 and be left with h. Which means that the formula there that I have on the bottom on the red is the slope of the line, which is actually the slope of the secant line. And that has a special name. And that special name is called the difference quotient. So if I ask you to find the difference quotient, I'm asking you to find the slope of the secant line. Let's write up here the difference quotient, which is f times x plus h minus f of x over h. Okay, so you're going to be using that a lot, and it's a little tricky to use. So we'll do some practicing here. Let's get rid of this and see see if I can. Oops. Okay, so if you look on page 137, we've got an example. And let me get to a new sheet of paper here. The example says that f of x equals 9x plus 5. Okay? That's all I've got. What do you know about that equation? What's it going to graph? What object or figure is it going to graph?
X.
What I'm asking for is for you to find the difference quotient. So we're going to take this handy dandy formula and plug stuff in and find out what the difference quotient is. Okay, so first step, we're going to find out what the function of x plus h is. What I like to do is to find each part of this and then stick them together. So I'm going to find this, then I'm going to find this, then I'm going to find this, and then I'm going to put those numbers in for those red circled parts and just add and divide, and then you're done. So find out what each one is first, then put the numbers up there and figure out the answer. So first thing I'm going to do is find my f of x plus h. Okay, so f of x plus h equals 9 times x plus h plus 5. Okay, and we'll stop there for a minute just so we can make sure you see where this guy came from. Take our original equation, 9x plus 5. And what this function right here says, whenever you see an x in the original equation, the top one there, the 9x plus 5, whenever you see an x, put whatever is in the parentheses in place of the x. So see how I did that? Took the parentheses x plus h. Wherever I saw an x in that top equation, I put x plus h in there. Okay, now we distribute. 9x plus 9h plus 5. So that is my f of x plus h. So that's done. All right, let's start with the second part here. Second part says find our f of x. Well, f of x we already have, right? Our f of x is 9x plus 5 in our original equation. Okay? Next step is find h. There's no way we can find h. I mean, there's nothing there. So we just leave it at this point, hoping that something good will happen later on. All right, so what we're going to do for step 3 is we're going to put all this stuff together. So there's my f of x plus h. I'm going to write that here. Plus f of x, which in this case is 9x plus 5. I'm sorry, I'm messing things up here. That's a minus sign. Did I have it is a minus sign on the original one, I wonder? Yeah, I did. Okay, so I just wrote it wrong there. So that means I wrote it wrong here. Okay. My mistake. Okay. Over h. Okay. Did I write that correctly?
If you have a minus sign there, is it minus 5?
Yes, that's still in parentheses. If I take the parentheses off, then I have to change this to, like Erica said, 9x minus 5. Okay, once I have it written correctly up there, then I combine like terms. Okay, so you see any way to combine like terms, Tim? Anything common?
Yeah, 9x and 5.
So I can cross out my 9x's because 9x minus 9x. What about, oh, and my 5's. Thank you. And I'm left with 9h over h. Which means, yes, Erica, I can cancel. So what is my difference quotient? Or my average rate of change is also what that's called. Remember we were talking about that the other day with the Ford, or the trucks? Average rate of change, or the slope, is 9.